In this lecture, we look at the simple.cpp program again, but with added complexity. In OpenGL programs, we define and render any object in 3 steps. Step 1, we put all its vertices in an array. For example, vector 3 points, which has 3 vertices, and then we populate the array with the 3D locations of the vertices. In step 2, we send the array to the GPU. In step 3, we tell GPU to render the points as a triangle, for example. Recall that this is the retained graphics mode. Let us revisit the simple.cpp program again. However, this time the main function will have added complexity, mostly calling glut functions. The init function will incorporate color. The init shader function will see this in detail later. The key issue is that we must form a data array to send to the GPU and then render it. Here is a more complex version of simple.cpp. Angel.h will also include gl.h, glextension.h, freeglut.h, vector.h, mate.h, etc. We initialize glut. We initialize the display mode. However, this time we use double buffering with added glut depth. So this basically gives us double buffering and a depth buffer as well. Double buffering we'll study in detail later, but it is sufficient to know now that double buffering helps in smoother graphics. The depth buffer helps in removing hidden surfaces. This is similar to previous version, except that now we have a window size of 500 by 500. We additionally define where we want to place the window, which is at the top left corner of our screen. We also give 2 extra commands which tells our program to use OpenGL 3.2 core profile, glut init context versions, which is 3, and subversion 2. So that's basically OpenGL 3.2. This is similar to what we studied before. This will create a window and will name it simple and will display the simple name on the window pane as well. Now we define the display callback function. So every time the display needs to be refreshed, my display function will be called, and this is what we will have to write ourselves. We initialize the glue over here with glue init. We call our initialization function here, which we have written in our simple.cpp, and finally we return we enter an infinite event loop using the glut main loop command. We also add return 0, which actually never returns because this is where the program sort of goes into an infinite loop. Glut functions. Glut init initializes the glut system and allows it to receive command line arguments. Always include this line in your code. Glut init display mode requests properties for the window, that is the rendering context. RGBA color is default, or you could also use indexed color, but it is rare now. Double buffering is usually used for smoother graphics, or you could perform single buffering to save resources, but this will put in redraw flickers. Depth buffer is requested when you have 3D graphics. It additionally stores depth of each pixel with respect to the camera, and this depth value is used to decide which parts would be visible. This is generally used in combination with GL enable GL depth test. We can use other properties such as glut alpha, that is generally for special condition window buffers, which we will not talk about now. But the important thing to note is that all these properties are bitwise ORed with this bar that we place in between these properties. Hence we can select one or any number of rendering context properties for the glut init display mode. Glut window size is fairly obvious, that it defines the size of the window in pixels, and the glut window position basically defines where the window will be placed when the program first runs. Glut create window creates the window titled simple. Many functions need to be called prior to creating the window. Similarly, many other functions can only be called afterwards. Glut display function sets the display callback. So we have already studied this. Glut keyboard function sets the keyboard callback. So this function would run if you hit a key of the keyboard. And inside this function, this callback function, you would define what happens when a certain key is pressed. Glut reshape function sets the window resize callback. So every time a window is resized, what should the OpenGL do? Glut timer function sets the timer callback. Glut idle function sets the idle callback functions, which is basically what should OpenGL do if the system is idle. Glut main loop, we have studied this. This basically puts the program into an infinite loop. Once we get data to the GPU, we can initialize the rendering with a simple display callback function. We call it the myDisplay callback function here. The first command here is to clear the buffers, and then we tell it to draw the arrays as GL triangles, starting with the first index position and using 3 vertices to draw the triangle. That is, if we had more triangles, we would specify a higher value over here. And now, instead of using GL flush, which we used previously in our simple.cpp, we replace it with GL swap buffers. In this case, rather than flushing the buffers, we swap the current buffer with the front end buffer. This is called double buffering. So while OpenGL is filling up the back end buffer, the front end buffer is being displayed. And once the back end buffer is completely filled up, it swaps the 2 buffers. This reduces or removes the flicker from the display.